All right, welcome to Lab 4. This lab is going to be about relations and modeling them in code. So let's figure out how to do that. So let me draw some examples first, and then we'll talk about like what's going to go on. But inside of our lab, inside of our computer, we're going to model the fact that we have a relation as a set of pairs, because that's technically what a relation is, right? You write some dots and some arrows, and like essentially it's like each arrow is a pair. Right? It's the start of the arrow and the end of the arrow. So, yeah, a set of pairs, and also our relations in this lab will be on ints. So it's going to be a set of pairs of ints. And so we're going to be working a lot with set, this type right here, set, pair, int. So a set of pairs of ints. You see how I'm reading that? So, all right, let me give you an example of how you might model these. So first example, let's do an injective function. So a function that is one-to-one, and we will figure that out together. So let's see here. Because you can have relations that model functions. That's just like a fancier amount of conditions that you have. Every function is a relation, but not every relation is a function. So we can totally model functions as relations. So here's my example. Let's say we're going to relate integers. So all of these dots are going to be numbers. So like this is dot number 1, dot number 2, 3, 4. I don't know why I did it in this order last time, but I'm going to keep the order that I planned. So let's say this is our domain, and 1 gets mapped to our function that we're modeling. It maps 1 to 2, it maps 3 to 6, and it maps 5 to 7. And so implicitly, just the things being mapped, those are the entire domain. So like this side, all these things are the 3 things that are part of this function's domain. Okay, so that's how that works. So implicit domain when we're modeling things inside of a computer. Otherwise, we'd have to like represent like, oh, this is what the domain is separately. No, we'll just take that the things being mapped make up the entire domain. And so how do we represent this in code? This is like R1, relation 1. It is a set of pairs of ints. And we can do it like this. So how do we represent this arrow? How do we store that as inside of this set of pairs of ints? Well, it's an arrow from 1 to 2. So you can write it as a pair 1, 2. See that? So just like, so 3, 6 is that one. And then 5, 7 is the last one. And so that is all you need to specify what this relation is, right? Assuming that you're going to implicitly mark the domain. It's just like the things on the left side of arrows. Those make up the entire domain. That's what we're going to do for this lab. All right. So that's our first example. Let's do another example. Let's have an example of a relation that is symmetric. All right. So let's draw some more dots and number them. So we're relating ints. Each dot has a number associated with it. So let's say this is 1, 2, 3, 4, 5, 6. Those are our dots and their numbers. For some reason it bothers me that this one is so far away. Move over here. And so let's do this one. So I'm going to model a symmetric relation. So the second I put this arrow, I must also have this one, yeah? And then the second I put this arrow, I must also have this one. And then when I put this arrow, I better also have an arrow going from 6 to 5 as well. And that's what it means to be symmetric. You always have the other direction hanging around. 4 and 3 just aren't relating to anybody. That's fine. And so let's call this R2, relation 2. And so how would we model this in code? Well, again, we'd say we just write down all the arrows. So this is an arrow from 1 to 2. That exists. And because it's symmetric, we also have an arrow from 2 to 1. And so we'll model it like this, 2, 1, where the order matters, right? We have 2, 5, and 5, 2. And then finally 5, 6, and 6, 5. And so you can exactly specify what is in this relation with just a bunch of pairs. It's just a set of pairs of ints, assuming it's the ints that are being related. All right, so that's what you're going to be given in your lab, relations that look like this. And you're going to have to like think about what does it mean. Okay, so let's go to the write-up now, and we'll talk about that. So here's the write-up. So yeah, it's pretty straightforward. You get the lab, here are all the files. I've got some files with relation stuff, of course. And then really the one thing that you're doing is you're going to implement this relation class that I've made. So I've made it in relation.h, And so you're going to be implementing all the methods of this relation class that represents a relation on ints in relation.cpp. For every relation that we talk about, the elements are ints that are being related. Right? So if you see something like a comma b in the set of the pairs, just like this, you see 1 comma 2 in your set of pairs, that means that a is related to be in that order for this relation that we're considering right now. Okay? So yeah, let's go to the code. Let's talk about them, and I'll give you some examples of the code too. All right, give some drawings. So yeah, relation.h is where we're going to be implementing things. Oops, relation.h, and so here's the relation class. Okay, so every relation is made up of, through the constructor, a set of pairs on ints. So those are the elements in the relation, and it's going to represent a binary relation on 2 different subsets of the integers, potentially. All right, so you can also just think about it as relating integers, if you don't worry about functions at least. So yeah, here's a bunch of methods that will make sense, right? You're going to save away these elements and then start asking about your relation. Like, all right, is x related to y? That's an easy one. Just look at your elements, right? I'll talk about these in just a second. This is a method that will return whether or not your relation was a function, right? You remember what it means to be a function? Can't be mapping something too many places, stuff like that. Is injective. If you got a function, you can ask if it's one-to-one. So that's something you can consider. Technically, we cannot test for surjectivity unless we somebody tells us what the codomain is, because that's what it means to be surjective, right? We have to know what the codomain is, and we weren't getting that. So we're gonna just test for injectivity only, just one-to-oneness. Here's a method that checks if our relation that we're storing right here is a symmetric one. So you got to go looking for things, right, to test if it's symmetric or not. And then this one will return if it's transitive. Okay, so that's the idea. And again, we can't test for reflexivity because of the way that we're representing these relations. We don't know, like, are these the only elements in the domain of the relation? Somebody would have to give that to us if we were going to test for reflexivity. But in that case, we are good with all these. Okay, that's what we got. That's what we have to work with. And so all these things you'll be implementing in relation.cpp. All right. Oh, I should talk about the other two before we get to this file. So is related to left and is related to right. Let me just read you these ideas. You'll look at this later. But is related to left, it finds all the things. You give it an x, right? It's going to find all the things that x is related to on the left. So that those things will be on the left. Find all the y such that y is related to this x. Does that make sense? You're going to generate a bunch of things, a bunch of ints, right? So you're going to return a set of ints. And then finally, also is related to right is the same idea. It's like you give it an x, and you're going to find all the things that are related under this relation to this x on the right. So x is on the left. What are all the things, what are all the y's on the right that x is related to in that order? Okay, that's the idea. So that's what those two return. That's what they're supposed to do. So yeah, I've started off this with the constructor, just setting the elements into our member variable, and then it's your job to do the rest. Okay, so you're gonna check, like, you're gonna implement this method, for example, like is x related to y? Return true if they are and false if they aren't. So like fix this. So this is just really look it up in your elements, because that's telling you when things are related, right? So there's that, and then is related to left, is related to right, all these other things. We'll talk about them in a second. So let me draw some pictures at least. Like, let me spell out like what it means to test for is related to left. So let me take these relations that I drew here so carefully, and I'll plop them right here. So here are those relations. Let's see some stuff. Let's test some things about them. Okay. So let's go there. I'll get a green pen now. And so let's talk about what it means to call is related to left. Like this is, let's say this is relation 2. Let's say that we're asking for R2, like we're going to call it R2 in our program. R2 dot is related to left on, let's say, the number 5. All right, so all the things that 5 is related to on the left. Okay, so that's what that means, is related to left. Find, return all the y such that y is related to x, the x that you're given. That thing that was passed to you, and you're returning a set. All right, So essentially what we're looking for is like, all right, we're given the x, find all the x's on the right of our relation. So like we're passing 5 here. So find all the things that look like blank related to 5. You see that? Find all the things that look like blank related to 5. And so looking at our relation, what are all the things that are related to 5 with 5 on the right? There's a thing with 5 on the right. There's another thing with 5 on the right. Those are the only 2 things. And so our job is to give back those 2 things that 5 is related to on the right too. Okay, so it's related to the 2 and the 6. So this would return then, because your job is to return a set of all the integers such that those things are related to on the right, such that, sorry, x is related to on, oh, did I do it backwards? Sorry, I was saying left. I was saying right and I meant left, excuse me. So here we go. So x is on the right, all the things that x is related to on the left by. All right, and those are the, here are the things on the left of that 5. It's the 2 and the 6. All right, I hope that makes sense. Please yell at me if it does not. And then, like, you could also ask things about, is something a function, right? You can ask, is R1 a function? You have to go and check those things. R1.isFunction. It's meant to be a function, so this should return true. Why? How are you going to check, right? You better make sure that, like, everything is being mapped to only one thing, right? That's one of the things that make up a function. So check all those requirements to be a function that your book talks about. That's a big one. Like make sure that 1 is not going to multiple things. I think that might be everything for this one. That'll confirm that this is a function, right? Not going too many places. And also this is an injective function. So how would you check that? Is injective. That'll also return true for this relation 1, right? Because we're assuming implicitly that this is the domain, everything that's on the left side, all these things, those are the entire domain, okay? And so you'll just check like, hey, did any of these equal each other? If so, like we're mapping different inputs to like the same output. If this like also went to 2, then it wouldn't be, right? This wouldn't be 1-to-1 anymore. It wouldn't be injective. So that's kind of how you'd check that. So, do I give you any comments about that? So yeah, for is function, like really, you can just check that for every x, there's exactly one y that it's related to. Okay, it's like it's not going off to multiple things. So that's all you'll need to check for this lab. For is injective, it's just like, remember that your relation is working like this. X is related to y if the function on x is the input on the left, the output's on the right y. Okay. So it's injective if no 2 x values share the same y value. So like this is injective, but if I removed this arrow and made this arrow instead, now 2 x values are mapped by the function to the same y value. You see that? That's a problem. That is not injective anymore. So that is the secret for that one. And then you could check other things, like is symmetric. I think you can imagine and see like how you would check that for a relation to R2.isSymmetric is for sure going to return true. Is symmetric. That better return true. Do you see how you might check for that? You'll have to like iterate through all your arrows. Like if you see this arrow, go looking for this one. Does that make sense? If you see this arrow, go looking for the other one. Swap them around. Check if the other thing's there with your is related to method. Yeah, helper method. That's perfect. Kind of see how that would work. So that's is symmetric, and then same for R1. Like R1.isSymmetric. You'd visit every arrow in the relation. Symmetric. That better return false, yeah. So you visit every arrow, like you see this one, you go looking for 2, 1, and you don't find it. So then you can just stop. You give up because it wasn't symmetric. Does that make sense? So those are the methods you're going to be implementing, and hopefully you can kind of see how you'll be doing it, because your relation is represented like this. You're going to go and iterate through a bunch of pairs essentially, which are saved in your member variable called elements. Okay, so that's what you'll be doing. Let's see, do I have any other hints for you? So here are some hints for these things that we talked about. For like is related to left, again, you'll want to iterate through every pair here, and you'll go and you'll check and find all of the elements where the right side was that x that was passed to you. So like this thing, go and find all the elements in your relation where x was on the right side, like I underlined here. So look at these and then return the left side of those. That's what it means. Okay, and then for is transitive, my hint to you, and this will also help you for is symmetric. If you want to do this, then you might as well iterate through pairs of arrows. Does that make sense? It's like if you're checking if something is transitive, you want to like iterate through every pair of arrows, and if they ever line up, like if you iterate through this one, and if they ever line up in the middle right there, you got to like go looking for this arrow. Does that make sense? That's the secret. So that's what I want to tell you. So like if use a doubly nested loop, I would say if you ever see like something related to A related to B, call them, and then B related to C, where like the second thing in the inner loop is the same as it matches, right? The last thing in the outer loop is the same as the first thing in the inner loop. If they ever match like that, then you have to go looking for A mapping to C, A related to C in that relation that's stored there. So that would be the secret for all that kind of stuff. It's just you're looping through your elements of your relation potentially multiple times if you need to find pairs of them and relate them. So that is my hints, and really all that you're touching in this lab is going to be relation.cpp. That's going to be the one file that you mess with. I've made a bunch of tests for you in testrelation.cpp, and you don't have to write any of your own, but here they all are. You can use these and draw them out if you need to. Like this is an injective function. It's making sure that you can see that your code is making sure that it's recognizing it. And so here's a non-injective function, so it's a function, but it's not injective, so I'm testing all those things. A symmetric and transitive relation, a relation that's symmetric, but it's not transitive. So draw these out when in doubt and get them to pass. And yeah, that's everything. Like here's a relation that's not symmetric or transitive. So that's fun. So look into that, draw the pictures if you have any questions about stuff, and then also yell at me. But the one thing that you are messing with is relation.cpp, so that's the one file that you'll be turning in. Okay? So yeah, yell at me if you have any questions about that stuff, and good luck.